breathalyzers,
photosynthesis,
stale apples,
rust.
and matches. What do they all have in common? Redox reactions. Redox reactions are reactions which involve electron transfer. As we can see from its name, redox involves two reactions, reduction and oxidation.
One substance is oxidized, which means that it loses electrons.
On the other hand, the other substance is reduced, which means that it gains electrons.
To make it easier to remember, we can use the mnemonics oil rig
Oil, meaning oxidation is loss,
and rig, meaning reduction is gain.
Sometimes it can be as simple as adding electrons to balance out the charges. But other times it gets more complicated than that. Today, we will be talking about balancing redox reactions in both acidic and basic mediums.
First, let's talk about reactions in acidic mediums. Let's take this as an example. Let's work on this reaction between chromate and nitric acid to form chromium and nitrate. Let us work on balancing these two equations separately. We start with the elements that is not hydrogen and oxygen. On the first equation, chromium needs to be balanced, so we multiply the product side by 2. The reactant side has 7 extra oxygen atoms. We can balance this out by adding 7 water molecules to the product side. After we have balanced the oxygen atoms, we get 14 extra hydrogen atoms on the right side. Balance this out by adding 14 protons on the left side. We managed to balance all the elements on the equation, but the charges are still unbalanced, with a positive 12 on the left side and a positive 3 on the right. We can solve this problem through the use of electrons and by adding 9 electrons on the left side. Now that the first half reaction is balanced, with both sides having a total charge of positive 3, set it aside and move on to the second half reaction. Here, the nitrogen is already balanced, so we can proceed to balancing oxygen by adding 1 water molecule on the left side, and the hydrogen by adding 2 protons on the right side. And finally, to balance the charges, we add 2 electrons on the right side. Now, we have 2 balanced half reactions. But before we combine them, we must first make the number of electrons in both half reactions equal. We can do this by finding the least common factor of the coefficients of the electrons. The LCM of 2 and 6 is 6, so we multiply the second half reaction by 3. Finally, we combine these 2 half reactions before we cancel out the common terms. Now we have the balanced chemical equation in acidic medium. Yeah! Let's recall the steps. 1. Separate the half reactions. 2. Balance elements other than oxygen and hydrogen. 3. We can add oxygen by adding molecules of H2O. 4. Balance the hydrogen by adding protons. 5. Balance the charge of each equation with electrons. 6. Scale the reaction so that the electrons are equal. And 7. Add reactions and cancel out common terms.
Now, we can move on to balancing redox reactions in basic conditions. In basic conditions, you also follow the same steps as in balancing in acidic conditions, but you have some additional steps. Let's look into it further with this example. Here, we have the reaction between silver and zinc 2+ to form silver oxide and zinc. As mentioned before, we follow the same steps as we did in balancing in acidic conditions. First, we separate the half reactions. Then we balance elements other than O and H. Like before, we balance out the oxygen by adding H2O molecules. Then, we balance the hydrogen by adding protons, then we balance the charge of each equation with electrons. In this step, there is no longer a need to scale the reaction since the electrons are already equal for both reactions. Now, we can combine the two half reactions and then cancel out the common terms before we proceed to the additional part for basic reactions. Now, we need to remove the additional protons since this is a basic solution. We can balance those out by adding OHs to both sides. Next, we combine the H plus and OH ions to form water. Finally, we cancel out the like terms once again in order to arrive at our final equation. So, to recap, we have the first 6 steps of balancing redox reactions in acidic medium, plus adding OH to balance out H, combining OH and H ions on the same side to form water, and finally canceling common terms. And that is how you balance redox reactions in basic medium.
But it's not over yet. If you want to test your skill in balancing redox reactions, now's your chance.
We will be flashing examples of redox reactions in the screen, and it's up to you to balance them out. The answer will be revealed after 5 seconds. You can pause the video to take your time in answering. Thank you for joining us today on our take on balancing redox reactions. We hope that you learned a lot from our video and that you have taken a little bit more interest in the field of chemistry.